Hello friends, here in this video we will see a problem on pentagonal pyramid which is to be cut. So here is a question. A pentagonal pyramid, side of base 35 mm and height 70 mm, rests on its base on HP with one side of base perpendicular to VP. It is cut by an AIP, that is auxiliary inclined plane, such that the true shape of a section is an isosceles triangle of maximum possible base and minimum height. Draw its front view, sectional top view and true shape of the section. So this is the question in front of us. I'll explain the conditions step by step. First I'll draw the diagram for the pentagonal pyramid. So here we have the diagram of a pentagonal pyramid. Question is, pentagonal pyramid, side of base 35 mm and height of axis, that is the height is 70 mm, rest on its base on HP. So here I can say that this pentagonal pyramid is resting on HP, also called as the ground, on its base with one side of base perpendicular to VP. This condition I'll explain in the solution part. Next, here we have the apex. These are the slant edges. Pentagonal base, and triangular faces. Now, so here I have given the notations. Then with this we can easily start with the solution part. So I'll start drawing the pentagon. It is resting in HP. So if it is resting in HP, in that case, from the top view we are going to see this pentagonal base, and in the front view we will see these triangular faces. That is, in HP the pentagon will be there, and in VP there will be the triangular faces. Now here I have to draw the pentagon in HP, but the condition is with one side of base perpendicular to VP. So how to draw that I'll explain here. Light horizontal line, and then I'll plot it little bit below. Light vertical line. Then the side of base is given as 35, so I'll measure 17.5 on one side and 17.5 on the other side. Next, the edges of the pentagon are inclined at 72 degree. From both the sides, drawing a light line through it, inclined at 72 degree. Similarly onto the other side. Next, measuring the base, which is 35 given. So cutting an arc here. Joining the points. Then I have to locate the apex. For that I will have to take half of any one of the sides, that is the midpoint, join it to the opposite corner. So here is the apex, point O. I'll give the notations here. Now I'll plot these points in the front view, and just before that, joining these points or corners at the apex, because here we have a pentagonal pyramid, so the slant edges are visible from top. Height is given as 70 mm. Measuring 70. Forming these slant edges. Next, I'll give the notations in the front view. Here is the apex, O dash, 1 dash, 2 dash, 3 dash, 5 dash and 4 dash. Now after drawing it light, I'll read the condition, because I have to locate the cutting plane and see what kind of a section is there. Here it is given: pentagonal pyramid, side of base 35 mm and height 70 mm, rest on its base on HP with one side of base perpendicular to VP. So here I have shown one side of base perpendicular to VP seen in HP, and that side is 1 to 2, means this edge 1 to 2 is perpendicular to VP, it is seen in HP. Next, it is cut by an AIP, that is auxiliary inclined plane, such that the true shape of a section is an isosceles triangle of maximum possible base and minimum height. See the condition. The true shape of the section should be having maximum possible base and minimum height. So for that, the true shape will be here in HP, and before that on this top view there will be the apparent shape. And so as they have given that we want the maximum possible base, so the maximum possible base in this pentagonal pyramid will be from 3 to 5. Maximum possible base. And for minimum height, here what I'll do, projecting 3 5 upwards, that is 3 dash 5 dash. So this will be one end of the cutting plane, that is cutting point 3 dash and 5 dash. Next, to get a triangle we require one more point, but the condition is that isosceles triangle should have minimum height. For that, what we can do is, parallel to O dash 4 dash, I'll draw a light line. Next, here if we are looking into the top view, from 3 to 5, this much is the maximum, we can say, height of the triangle. But here we want the minimum height, means the height will be somewhere in between O to 4. In this region it will be less than this 0.4. So in order to adjust that, how we are going to do that? This from 3 dash to 4 dash, this is a parallel line. We want the distance less than it. So for that, one condition is keeping the point here on 3 dash 5 dash, we are going to drop a perpendicular on the edge O dash 4 dash. Now when we are drawing a perpendicular line through it, this line is perpendicular. Since we want the minimum height, for that we require the minimum length of the cutting plane, and that minimum length is only possible if I draw from 3 dash 5 dash a perpendicular line. This will give me the minimum distance. And now after getting this minimum distance, this is nothing but the length of the cutting plane. So here where it is cutting 3 dash 5 dash, I'll give the notation that it is A and B, and here over this point I'll say this is C dash. So here I'm getting A dash, B dash. It means when we are looking as an observer from the top, then the maximum part of the pyramid is removed, only this much part is remaining. So that I will have to make it dark. From 3 dash 5 dash up to 4 dash. Next from 4 dash to C dash. Only this much part of the pyramid remains. And now I'll project this point C dash in the top view. This is point C, and that will give us the minimum height. So joining it with the help of light line from B to C, and from A to C, so this is the triangle which will be visible from the top, and remaining this much portion will be dark. Whatever is there on the left hand side of this line, that has been removed. So I'll make it dark. Up to 4 it is visible. Then from 4 dash to C dash there is a line, so that this small portion will be made dark, connected. Next, only this much part is remaining. Here I will have to draw the section lines. So measuring 45 degree and drawing the cutting plane lines. Then after getting this sectional top view, I'll plot the true shape of the section and for that I'll make this cutting plane parallel to XY. Drawing a light line. Now I'll mark the length of the cutting plane. It is from A dash B dash up to C dash. This point I'll say it is A dash B dash. Here we have C dash. And then for the true shape of the section, we see A dash B dash are onto the same point, so projecting them. Here we have point A in the top view. Wherever A dash and A they intersect, that will give me point A in the top view. B dash is on this same line. Here we have C dash and C. So where C dash and C they intersect, that will give me point C. Now connecting these points in order. Maximum possible base and minimum height. So this is the minimum height. Making this cutting plane dark. Cutting plane A dash. Similarly here, cutting plane A dash. Now this is the true shape of the section. So this equilateral triangle has a maximum base and minimum height. Then I'll give the dimensions to it. Base side is 35 mm and height is 70 mm. True shape of the section, and with this we complete the problem.